Welcome back, grade 11s. We are looking at sequences and series, number patterns, of course. We looked at linear number patterns just before the break, and now we're going to move on to quadratic sequences. Now remember, with a linear number pattern, if you were to take those numbers and those values in that number pattern and plot it as a function, you would, of course, get a graph that looks like a linear graph. So you would get a straight line. When we talk about quadratic sequences, what do you think the plotting of these numbers would look like in your sequence? What type of graph? Of course, it would look like a quadratic function. If we had to plot these values, we would get a graph that takes on the shape of a parabola. All right. So a quadratic sequence, what is it? It's a sequence of numbers in which the second difference, it's the second difference, not the first difference, the second difference between any two consecutive terms is constant, right? The first difference, we know how to do that. We used it when we were looking at linear number patterns. The first difference is calculated by finding the difference between consecutive terms. So if I'm looking at the numbers 5, 20, 45, and 80, 20 minus 5 will give me a first difference of 15. And then 45 minus 20 gives me 25. 80 minus 45 will give me 35. All right, so those are the first differences. As you can see, those values are not constant. 15, 25, 35, not constant. But in a quadratic sequence, we expect that to happen because it's the second difference that is constant. So we find the second difference by taking the difference between the terms that we found in the first difference. So 25 minus 15 will give me 10, and then 35 minus 25 will also give me 10. So what we see is that the second differences are all equal to 10, and we know that any sequence that has a common second difference is a quadratic sequence. All right. Okay, so let's see, how do we work out the general term? This can take quite a while to work out. There's different methods you can use to work out the general term. By far the simplest method to remember to use is to use simultaneous equations, substitute values for n, substitute the position of the term n for n, and then substitute what the value is of the term as tn, and then you can get 3 simultaneous equations and solve them. It's quite a long way to do it, but it is your option, all right? Another way, which we're going to look at now, is if we know the general term is an squared plus bn plus c, then if I look at what happens when n is equal to 1, 2, 3, 4, it simply means substitute n as 1. If you do that, you'll get a plus b plus c. So that's your first term in your sequence. Second term, 4a plus 2b plus c. Third term, 9a plus 3b plus c. And then the fourth term is given by 16a plus 4b plus c. This always stays the same. It never changes. Your first term in a quadratic sequence will always be given by a plus b plus c. The second term will always be given by 4a plus 2b plus c. And that is why it helps us to work out a method that we can use to find the general term. Now the first difference, if I take term 2 minus term 3, I see that the first term in the first difference is 3a plus b. So it's literally if you minus 4a plus 2b plus c minus a minus b minus c, you end up with 3a plus b. Similarly, if you look at term 3 minus term 2, you'd get a second term in the first difference as 5a plus b, and then a third term of 7a plus b. Okay, to find the second difference, you now find the differences between the first differences. So you say 7a plus b minus 5a plus b, you get 2a, and then 5a plus b minus 3a plus b, you get 2a. So this always stays the same. The second difference will always be given by 2a. The first term of the first difference will always be given by 3a plus b. And the first term in your sequence will always be given by a plus b plus c. Remember, that's not even something you need to learn off by heart. You can work it out each and every time. Of course, it's going to take longer, and this is why we say maths is all about practice, because if you practice enough, eventually you just remember what the first term in the quadratic sequence is equal to, you'll remember what the second difference is equal to, and so on. But if you don't know how to do it and you're not willing to learn each of these expressions, then you can simply each time work it out. So substitute n is equal to 1, n is equal to 2, n is equal to 3, work out those terms, and then you can simply subtract to work out the first difference and then subtract those to get the second difference. All right. Or as I say, if you do enough examples, you will remember. Okay, so to write down the next two terms and determine an equation for the nth term of this sequence. So we've got 3, 6, 10, 15, and 21. All right, so to determine the first and the second differences, because in order obviously to work out the next three terms, we need to know what the first difference is, we need to know what the second difference is. So 6 minus 3 will give me 3, 10 minus 6 gives me 4, 15 minus 10 gives me 5, 21 minus 15 gives me 6. So this is my row of first differences. Okay, I now subtract those. 6 minus 5, that gives me 1, 5 minus 4, 1, 4 minus 3, also 1. So my constant second difference is equal to 1. All right? So we see that the first differences are not constant. There is a common second difference of 1. Therefore, we understand that the sequence is quadratic and it will have that form. However, if you look at the question, they said write down the next two terms. So we can do that without actually working out the general term. So let's just have a look at that first. So we know each time this row of first differences is increasing by a value of 1. All right, so if I say 21 plus, so 15 plus 6 gave me 21. So if I say 21 plus 7, that will give me the next term. 21 plus 7 will be 28. And then if we say 28 plus 8, we will get the next term, which is 36. So those are the next two terms in that sequence without actually working out the general term. Okay, but we want to practice working out the general term, so let's move on to doing that. Okay, so we know that 2a is the second difference, but I also worked out that in this example the second difference was 1. So therefore I can say 2a is equal to 1, so therefore a will be equal to a half. So in my formula, Tn is equal to an squared plus bn plus c. We know already that a has a value of a half. We just need to work out b and c in order to work out what the general term is. So this is where it's important to remember those things. For example, 3a plus b gives the first term of the first difference. But we saw that the first term of the first difference had a value of 3. So therefore I can say 3a plus b is equal to 3. But we know that a had a value of a half, so we can simply substitute a is equal to a half, and we'll get that b is equal to 1.5. All right? Now that we've got b and we've got a, we simply need to use another equation to find out the value of c. So a plus b plus c is equal to 3. How do I know that? Well, that's the first term of the number pattern of the quadratic sequence that you were given. So a plus b plus c is 3, but we know that a was half and b was 3 over 2, so therefore we can substitute and work out that c is equal to 1. 1.5 plus a half is 2. Take the 2 over to the right-hand side. 3 minus 2 will give me 1. So therefore now my general term becomes a half n squared plus 1.5 n plus 1. And this general term can help you to find any term in the sequence. So if I wanted term 5 or term, we want to double check. Remember, we worked out 1, 2, 3, 4, 5. We worked out term 6 and term 7. So let's say I wanted to work out term 6. I can simply substitute 6 in place of n. So I'll get a half into 6 squared plus 3 over 2 times 6 plus 1. 6 squared is 36. 36 divided by 2 is 18. 3 over 2 times 6 will give me 6 times 3 is 18, divided by 2 is 9, plus 1. So 18 plus 9 is 27, 27 plus 1 is 28. And let's go back and see what we got. We did get that the sixth term was 28. So you see that this general term can be used to help you to find any term in the sequence. And that is why it's so important for us to remember how to work out the general term. Okay. So let's just recap what we've learned. We know that in a quadratic sequence, the first difference is not constant. The second difference, however, is always constant. We use the general formula Tn is equal to an squared plus bn plus c. And what I'm going to add there, to add to that is we also need to remember that 2a gives us the second difference. We need to remember that a plus b plus c gives us term 1 in the sequence. And then it was 3a plus b that gave us the 3a plus b gives us the first term of the first difference, so it's the first term of first difference. Okay, we're going to quickly go over another question that's going to get you a little bit further, and then you're going to try and finish it off for yourself. So in this example, we are asked to find the equation for the general term, and you've got the numbers given to you in that sequence, and then we're going to use the equation to find term 100. So to start with, I'm just going to get you started, and you need to finish it off. So we set up 7, 13, 23, 37, and 55. All right. First thing we do is we find the first difference by subtracting term 2 minus term 1. 13 minus 7 is going to give me 6. 23 minus 13 will give me 10. 37 minus 23, is that 14? Yes, it is. And the next one, 55 minus 37, 5 minus, I have to do this in my head. We've got 18, I think it is. Let's just double check that one. So we've got 55 minus 37, 18. Fantastic. All right, now we're going to find the second differences. 18 minus 14 is 4. 14 minus 10 is 4. 10 minus 6 is 4. So therefore, we can see there's a constant second difference of 4. Once you've gotten to this point, guys, you've established that this sequence is in fact quadratic because there's a constant second difference. So now you can use all the technology, or not technology, all the tools that we've learned so far to help us to work out the general term of this quadratic sequence. Once we've got that general term, we can then substitute n with 100 and work out the value of term 100. But I've already set you up. You know that the second difference is 4, so you can work out the value of a, b, and c from there. All right, guys, until next time, I think it is time for us to say goodbye. Take care. Cheers.